In this video, we're going to go through on Nanhua Primary School Primary 5 with the assessment Term 2 2024. So let's get started on the first question. Question 1. In a triangle DEG below, which base is related to the height E and F? So we have E and F as the height. So which one is the base? Okay, so in this case, we always want to look at the perpendicular box over here, right? So if this is the height, let me put a highlighter over here, then where is the base? So the baseline will always meet the perpendicular box over here, right? So that means that the line that is meeting the height is over here. Okay, so you might think the answer is D and F, right? But the thing is that for any baseline, it is always a solid line. Okay, so that means in this case over here, the dotted lines is not the base. So the base itself is only D and G. So the answer in this case is D and G, which is number 2 over here. Okay, so let's move on to the next question. Question 2. ACDE is a rectangle and find the area of the shaded triangle E, B, and D over here. All right, so first thing is that we already know what's the base, which is 10 centimeters over here. What was the height? The height is in the middle. So I'm just going to draw a line like this. Okay, and I'm going to like remove, oops, a bit here and there, right? So this is the height. Okay, so this is the height. So the thing is, what is the height of this triangle? That's what you see over here. So the thing is that if it's in the rectangle or a square, then we can actually get a height. So the height is here, but it's also the same height as, let me just move this here. So that means the height, the height over here is the same as the height of this rectangle. So that means this height is 6 centimeters. So I'm going to highlight this as well because it's the same height. Obviously, see over here. So this is 6 centimeters. So now we know the height. It is basically half times 6 centimeters times the base, which is 10 centimeters. So we cancel 6 with 2. This will be 3. And this will give us 30 centimeter square. So the answer is number 3, 30 centimeter square. Let's move on to question 3. The figure below is not drawn to scale. So what is the ratio of the length of eraser, length of pencil, and length of crayon? So if eraser, pencil, and crayon. So we're going to write down as the words over here. So it's easier to us to see. So eraser, eraser. Then also we have our pencil. Then we also have our crayon. Okay. So our eraser over here, if you were to look at it, it starts at 3 and ends at 6. So that means in between, it should be 3 centimeters. So I'm going to put it down for the eraser 3, right? Let's go to the pencil. So the pencil starts at 0 and then ends at 11. So this is pretty straightforward. For pencil, it is 11. So if you see the option over here, which has 3 and which has 11, option 2. So that's the answer. Option 2. All right, let's move on to question 4. Okay, question 4, it says here, Ali bought 36 chocolates and 64 sweets. Find the ratio of number of chocolates to the number of sweets and chocolates. So we're going to write it down. So choc, I'm going to short form it, choc, and then the ratio to sweets plus chalk, right? Okay, so now we know what's the number for chalk, which is over here, 36 chocolates. So we're going to write down 36. And then 2, the sweets plus the chalk. So the sweets is 64, right? Oops. So let's, okay, sweets is 64. And then we have plus chalk, right? So the chalk is 36. So 36 over here. Okay, and this basically gives us 36 to the what do you call this? 100 over here, right? So 64 plus 36 is 100. So what can we do to simplify it over here? So what is the common factor in 36 and 100? So if you have, for example, 36, and if you have 100, so you have, the 1 times 36, 1 times 100, not really the case here. The next one is 2 times 18, this 2 times 50, not really. 3 times 12, 100 can have 3, nope, because we can't do that. About 4, 4 times 9, and 100 4 times, if you have 100 divided by 4, is 25. So you can see that our common factor over here is 4. So common factor, lowest common factor is 4. So 36 divided by 4, 100 divided by 4. So the answer is 9 to the power of 25. So that is option 2. So the answer is 2. Last multiple question, question 5. So Ava, Betty, and Charles have $77 together. The ratio of Ava monies to Betty monies to Charles money is 1 is to 4 is to 6. How much money do Ava and Charles have together? So I'm going to put Ava as A, Betty to B, and Charles to C. So we have the ratio over here, right? 1, 4 to 6. So I'm going to write down. Oops. So give me a second. All right. So over here. Okay. So 1 is to 4 is to 6. So what is the total units? Which is 1 plus 4 plus 6. Why do we want to get the total units? It's because we know how much all of them got, which is $77. So total units is 11. 1 plus 4 is 5. 5 plus 6 is 11. So if 11 units, I'm going to put U as short for units, is $77, then 1 unit is equal to 77 divided by 11, which is 7. So now we want to know how much do Ava and Charles have together. So Ava and Charles, so A plus C is equal to 1 plus 6, 7 units, right? Ava and Charles is A and C. So we want to get 7 units is equal to 7 times 7. Okay, and this will be $49. And option 4 is the correct answer. Let's move on to question 6. All right, let's move on to question 6. Find a missing number in the box. We have a ratio over here. Okay, so we can actually simplify this 6 is to 9 over here. So what is the common factor between them? So you have 6, 2 times 3, and you have 9, you have 3 times 3. Okay, so the common factor is 3. So we can divide by 3, and this will give us 2 to 3. So now, if you want to go to 14, in this case, right, what do we have to multiply to? So 14 divided by 2, pretty simple, 7. So that means for 3, we need to multiply by 7. And this gives us 21. So the missing number is 21. All right, let's move on to question 7. So the following solid is made out of 1 centimeter cube. What is the volume of the solid? Okay, so 1 centimeter cube. So to get the volume is basically you need to get, let me just draw a simple cube over here. So you need to get length times breadth times height. So, and each of them is 1 centimeter. Cause a cube, all of the sides is the same. So basically, if a cube is 1 times 1 times 1, this will give us 1 centimeter cube. So the volume for each cube is 1 centimeter cube. So it's pretty straightforward. Now we need to count. So over here, we have 1, 2, and 3. So that means this is 3 cubes length, right? 3 cubes length, and then let's see what the width over here. It is 1, 2, 3, and 4. So this 4 cubes. So I would say this is first layer is equal to 4 times 3. And this gives us 12. Okay. So the next one is we can count it. We have 1, we have 2, then there is at the back 3, and then this is here. So the second layer, we have 4. And then last one, we only have 1 and 2, right? So this would be the third layer, which is just 2. So if you add them up, 12 plus 4 plus 2, and this gives us 18. Since we have 18 cubes over here, then we just multiply 18 times 1 centimeter cube. So 18 cubes times 1 is 18 centimeter cube. All right, let's move on to question 8. Draw a cuboid A on the isometric grid provided. So over here, basically you can see there is 3 units, 3 units, and 2 units. So this is pretty straightforward. What you can do is you can just see the 3 dots. So you can, for 3 units, you probably need 4 dots. So 1, 2, 3, 4. So what you can do is you can just draw one straight line down, 3 units. Okay. Then at the same time, you also need another 3 units over here. That means 4 dots or 1. So 1 dot, 2 dot, 3 dot, and 4 dots, right? And then we're gonna draw like this. Okay. And then the height over here, what is it called? Yeah, the height over here is 2 units. So we're gonna put the height. So it's 3 dots. So 1, 2. So this is 2. We're gonna put 2 over here. 1 is to 2. And then we're gonna put 2 over here. This is 1 is to 2, right? And then we're just gonna connect them, right? That's what you see over here. Okay. 1, 2, and then we're gonna continue as such. So I'm gonna move this down. Okay, so I'm gonna move this down over here. Okay, and then after that you can continue. So this is straight over here. We're going to put 3 units over here, and then we're just gonna connect them as well, like this. Okay, and then after that's it lah, right? So the dotted lines is not very clear, but make sure that you know. So 1, 2, 3, and then we have 4 over here. Sorry, so this is 4. So 1, 2, 3, 4. Okay, and then after that you can connect this to this as well. That's why I see over here. Okay, not very accurate, but give me a second on this, and then like that. Right, I don't want to curve. Right. Okay, great. Look something like this. Okay, so it's not super accurate, but this is how it's supposed to look like for the isometric grid over here. Okay, so this is 3 units. So 1, 2, and then 3, and 3 units over here. So you have 1, 2, and 3, and then the height is 2. Right. Oops. Give me a second. This is 2. Oops. This is 2. This is 2. Okay, and then you just connect the dots accordingly. This is 3 as well. So this 3, and it is 1, 2, and 3. It's 3 as well. Okay, so this is how you draw a cuboid in the isometric. The next part is the solid below is made up of 9 cubes. Draw the top view of the in the provided grid. Okay, so if you were to, for example, shine a light above here, okay, the the light is a sun over here. So what will be in a way shaded? You have this, you have this, you have this, you have this, and you have this. So there is technically 3 over here. So we have 3, and then we also have 2 over here. So 3 length, right? So we have basically 3. So 1, 2, and 3 cubes. That's what you see over here. Okay. And then on the other side, we have 2 over here, right? So we can just have 1 and 2. And that's roughly about it. Okay. So the thing is that they want it to be in the top view on the solid line over here. So essentially, we can just do 1, 2, 3. Okay. And then 1, 2 over here. And then 1, 2 over here. 1, 2 over here. 1, 2 here. Oops. Can I do this? 1, 2. this. 1, 2, 3, here, and here. That's basically it. And then we just connect the dots. That's what you see over here. Okay, not so perfect, but it's actually look like this. All right. So yes. So the front view is there, the side view is over there. Yeah, there you go. Let's move on to the next question. Question 10. So question 10, David is 12 years old, Ellie is 9 years old. Find the ratio of David's age to Ellie's age in 3 years' time. Okay, so David in 3 years will be 12 plus 3, and this guy's 15. And then Ellie in 3 years is equal to 9 years old plus 3. This will give us 12. So now we want to know David and Ellie. So David, the ratio to Ellie is equal to 15 is to 12. And what is the common smallest factor between 15 and 12? So 15, 12. So, oops, sorry. 12. So we can divide by 2 times 6. You can't divide 15 with 2, but you can divide 3. So 3 times 5, and then 3 times 4. So you can see the smallest common factor is 3. So that means for 15, we will have divided by 3. This will be 5, and this will be 4. So the answer to this will be 5 is to 4. All right, let's move on to question 12. ABDE is a square and BCD is a triangle. Find the area of triangle BCD. So ABDE is a square. So square means all of the sides are the same. So that means this is 8 centimeters, this is 8 centimeters, and this is 8 centimeters. So now the next thing is we want to find the area of the triangle BCD. So BCD. So which is the base and height. So first look at the what do you call this perpendicular box. So that means the two lines that meet the perpendicular box or this small little square is the base and height. So I'm just going to highlight so that it's easier for you to see. So I'm just going to highlight this and highlight this. Okay, so we can ignore this part over here. So we can ignore this 10 centimeters. So we don't really need this anymore. Okay, so now we just need to have the area. So the area of BCD is equal to half times 8 times 6. So now we can just cancel 2 with 8. This will be 4. 4 times 6 will be 24 centimeter square. So the answer is 24 centimeter square. All right, let's move on to the next question. Question 12. ABDE is a square, BC equal to CD. So BC over here is equal to CD. The area of ACD is 15 centimeters square. What is the area of the square over here? All right. So the thing is that over here, it is the same. This is just half a square. Okay. All right. And the thing is that we also have this. These two lines over here are the same. Right. So let's do a little bit of like visualization. So you know that half of the square is a triangle, and the thing is that, for example, if this is 2 centimeter, for example, so this is an example, this is not the right answer. That means this is 1 centimeter, this is 1 centimeter as well. So that means if I were to just let's ignore this, just ignore this. So that means a let me put this here as well. I'm gonna say this is so basically the area of triangle ABC. Okay, so I'm gonna highlight this as well. So ABC over here, ABC, right, is equal to, you have half times 2 times 1. Okay, then the area of let's put another highlighter. So this, and this as well, it is also the same, because for triangle A, D, and C, right? If I were to just remove the highlight over here, okay. So at the same time, let me just black this out. Okay, I'm just gonna black this out so it's less confusing. So then that means, right, the height over here, the height for ACD is, in this case, let me just put this over here, right, 2 centimeters. And then I'm just gonna make this dotted line as well. Okay, and then I'm gonna remove this. Okay, so basically the height of ACD is 2 centimeters, because the corner over here is actually a perpendicular line. So remember, perpendicular line, that means this is the base and height. So we also know earlier that the base is always a dot, what do you call this? A solid line is not a dotted line, but the height can be a dotted line. So 2 centimeter by 1 centimeter in this case over here, right? So half times 2 times 1. So basically, ABC and ADC is the same. Okay, if you were to calculate, this is just 1, this is just 1, because we cancel 2, this is 1, right? So this ABC is equal to ADC, right? So the area ABC is equal to ADC from this simple example. So that means, right, if I were to just remove everything else, that's what you see over here, right? So in this case, A, ADC has, or ACD, I'm just going to put ACD so it's easier. ACD, because it says here ACD is 15 centimeter. So ACD is 15 centimeter square. That means ABC is also a 15 centimeter square. That's what I see over here. So this is 15 centimeter square. And the thing is that AB, like half of the square, right, is equal to triangle ABC plus triangle ACD. And this is where it is equal to 15 plus 15 equal to 30 centimeter square. So this is half. Then what's the full? So the area of the square, or ABDE, is equal to basically 2 times 30, which is 60. Right? So the answer is 60. Whoops. 60 centimeter square. Right? Okay, let's move on to the next question. So this is paper 2. Paper 2. All right, let's move on to paper 2, question 1 for Nanhua term 2 weighted assessment. So over here, the box is filled with some 1 centimeter cube. All right. Okay. So now we need to know what's the volume of the box. Okay. So essentially, 1 centimeter cube, that means, right, the length times breadth times height, or the volume, right, essentially is 1 times 1 times 1, because it's 1 centimeter cube, right? So we know that this is 1, and the length is 1 as well. So that means we can just literally count everything as 1, right? Okay, first thing is we need to know what is the, what is the length, right? So we just need to count how much is the length. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So the length here is 11 centimeters. Okay. So now the next thing is, what is the length times breadth? So let's do it over here. This is 1. So we have 1, 2, 3, 4, and 5. Okay, so this should be 5 centimeters. And lastly, oops, let me erase this. And then lastly, what is the height? So the height is over here. So it is, let me erase this. It is 1, 2, and 3. So this should be 3 centimeters. Okay, so with the length times height is basically 11 times 3 times 5, which is basically the answer over here is 165 centimeter cube. So we're going to put 165 centimeter cube over here. All right, let's move on to the next question. Question 1b. How many more 1 centimeter cubes are needed to fill up the box completely? Right, in this case. So we need to count how many cubes we have, right? So let's count it. I'm going to erase this. So we basically have, I'm going to put this in red. We have 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 15 and 16. And we have the middle one that we don't see, 17. So we have 17 cubes over here. So let me write here. So we have current equal to 17 centimeters cube, 17 cubes lah, right? Okay, so 17 cubes. Then we also know that the volume is 165 centimeter cube, which is also the number of cubes that we need. So what we need is basically 165 minus 17, and this gives us 148 cubes. So you see over here. All right, let's move on to the next question. Question 2. In this, there's actually 2 ways to do it. So I'm going to do the first way. So here ACF is rectangle, BC equal to CD. So this is equal to this. Find the area of the shaded part. Okay, so I'm going to put here, this is the same as over here. All right, so what we're going to do is going to calculate what is this length, right? So we know that this is 6 centimeters. So the leftover is basically 14 centimeters, right? So line CD is equal to 14 centimeters minus 6. This will be 8, right? So this is 8. And since this is the same as this is also 8 centimeters. So now we know what's this length. We need to know what this is as well. So AB is equal to 25 minus 8, which is basically 17. So now we know what AB, which is 17. Okay, why do we want to get this length? And this length is basically if we get the whole rectangle minus this triangle minus this triangle, then we get this, what do you call this shaded part. Okay, so first let's get the area of the triangle F, D, and E, which is basically this one. So this is pretty straightforward. It is basically half times base 25 times height, which is 6. Okay, and we can cancel this 2 to 3. This will be 75 centimeters square. Let's get the area for the next not shaded part, which is this A, B, and F. So A, B, and F is equal to half times 14 times 17, and this gives us 1. We cancel 2 with 14. This is 7. So 7 times 17, it will give us 119. The next part is we want to get the whole of the what do you call this? The rectangle. Okay, so the rectangle itself will be A, F, C, E, which is basically 14 times 25, which is equal to 350. Okay, and now to get the shaded area is basically getting the rectangle, which is equal to 350 minus 119 minus 75, which is equal to 156. So the answer to this is 156. Okay, so this is I would say this is what do you call this? This is answer one, right? There's another way to do it. Okay, answer one. So the other answer is we actually don't need to do some subtracting. So this is answer two. So for answer two, we don't need to minus. We actually can get the area already. So how do we do that? Basically, we can actually get. Let me just cross. We can actually. Okay, why not? I just do this instead. So we actually can cut this triangle into this shaded part into half, and this will make us what do you call this? A two different triangles as what you see over here. Okay, so first one, I'm gonna highlight it. Let's say this is okay. So the first one will get the triangle F C D over here, right? So how do we get? So we already know the base over here is 8 centimeters, but what is the height of this triangle? So if I were to just make this easier for you to see, actually the height over here is, if I were to just do this, the height is actually 25 centimeters over here. Okay, so now we know the height for the FCD triangle. We actually can get the first shaded area. So let's do that. So answer 2. Okay, so triangle FCD is equal to half times. So in this case, it is 8. The height is 25 and then the base is 8. Okay, so height is half times 25 times 8. So you can cancel 2 and 8. This is 4. This will give you 100. Okay, now let's do the second one. So second one over here is another triangle, which is basically, let me just erase everything over here. Whoops. Right. Let me just erase everything over here. Whoops. So answer 1. This is 8. This is 8. Okay. So the next triangle over here is this triangle, which is BC and F over here. Okay. So same thing, we have the base and what's the height for this? So if I were to make it easier for you, it's actually this, right? This. So now I just make this as dotted line now, so it's easy for you to reference. So in this case over here, we have the perpendicular line. And since this is the triangle that we're looking for, the height is actually over here. Okay, 14 centimeter. So since the base is here, the height is here. Okay, so now we can just do that. So it's, what is this? BCF. So in this case, BCF is equal to, oops, it's a bit thick, half times 8. That's the base. The height is 14 centimeters. So we put 14. So we just have, cancel this, 7 times 8. This will be 56. So now the shaded area is basically the two triangles, which is equal to FCD, which is this FCD plus FBC, right? And now we can just add them together. So this is FCD plus BCF, which is equal to 100 plus 56, 56, and this will be 156. Okay, so there are two answers for this. All right, let's move on to question 3. So question 3 over here. Alice, Peter, and John have some pens. The ratio of the number of Alice pens to the number of Peter's pens to the number of John's pens is 1 to 2 to 5. Each of the statement below is either true, false, or not possible to tell from the information given. Put a tick to indicate your answer. So I'm going to make this a little bit easier to see below over here. So Alice is to Peter's. Oops. Peter's is to John. So 1 is to 2 is to 5. Okay, let's read the first statement. Alice has twice as many pens as Peter. So sometimes you might not understand this and you might think this is true, but actually it is false, right? Why it's false is because Alice over here, it does not have 2 times of Peter's, right? So not 2 times, but Alice uh, has twice. Doesn't mean is Alice is times 2. No, no, no. So Alice has twice, meaning that basically Alice ratio must be 2 is to 1, right? But in this case, it's not. So that's why the statement is false, right? This only means that Alice to Peter should be 2 is to 1. So that's what it means by twice. Alice must be 2 is to 1 for Peter's in this case. Okay, so this statement is false. All right, let's read the next statement. If John has 40 pens, Alice and Peter will have 24 pens altogether. All right, so if John has 40, so let's put here 40. So from 5 to 40, what do we multiply to? So if your answer is 8, you are right. So that means we need to multiply everything by 8. So 2 times 8 is equal to 16. And then 1 times 8 is equal to 8 itself, right? So now we need to know whether the second part of this statement is true. Alice and Peter will have 24 pens together. So Alice and Peter will have 24 pens. So 8 plus 16, this will give us 24. And does it say 24? Yes, it does. So the answer is true. Okay, last statement. They have 56 pens altogether, right? So the thing is that we don't know how many pens they have. They have some pens, but they never tell if someone has a pen or an indicator of someone has more or less than someone else in terms of pens. So in this case, it is not possible to tell because they don't say any number of pens in this whole question over here. So this is what number 3 should look like. All right, the last question. This is a very, very tricky question. So ABCD is a square with sides 22 centimeters, and D and E is equal to DE is equal to EC. So I'm gonna put here DE is equal to EC. So figure AFBED has a total area of 198 centimeter square. So which one? So AFB E, D, and A has 198 centimeter as the area. Find the area of the shaded triangle. Okay, so it's a bit everywhere here and there, but let's slowly break this down. Okay, so how can we get the area of this shaded triangle? So first thing first, we know that, let's write it down, A, F, B, E, D. So this figure over here, I'm gonna like, okay, it looks like this. This is 198 centimeter square, right? So this whole, let me just do the highlights. This whole thing over here is 198 centimeter square. So the thing is that if we are able to get this area over here, and this area over here, we can get this shaded triangle. Okay, so that means we need to get the triangle AFD. Okay, so triangle AFD and triangle, so we need to add this triangle BFE. Okay, triangle BFE Okay, and then we basically minus this whole thing over here. So I'm gonna duplicate this. All right, so duplicate. So this minus this, and then we can get the shaded area. The shaded area or triangle, right? Shaded area. That's what we see over here. Okay, so that is essentially what we need to do over here. Okay, so now how do we get, let me just erase this. Okay, so how do we get these two triangles? Okay, so first thing first is that we can actually get this triangle, right? So how do we get this triangle? So what we want is this triangle. I'm going to shade this part. Okay, so to get this triangle, what we need to do is essentially, let me just highlight. We need to get this triangle over here, which is very straightforward, right? So let's get this triangle first. Then we will need to minus this triangle. I'm going to shade this as red. So if I get the big half triangle minus this red shaded triangle, I can get AFD, right? So let's do that first. So first, let's get the area of the purple highlighted triangle, A, B, and D. So since this is a square, this is also 22 for A and D. So this is basically half times 22 times 22. So it's basically 11 times 22. This should be 242. All right. Then now we know what's ABD. How do we get AFB over here? Right. So if you remember, we know AB FD. So I'm going to erase everything here first. Okay. So we know that this, let me just highlight over here. So this AD, AF, B, and ED over here, we know this is 100. I'm going to put here as 198. That's what you see over here. Or let me just, yep, I'm just going to write everything like this. 998. Now, the thing is that to get this, we just need to know what this is, right? We need to go what the triangle, what is this? B, C, and E, right? We need to know this. Okay, so we actually know since this DE is equal to EC, which I accidentally erased. So in this case, DE is actually 11 centimeters and EC is 11 centimeters, and this is a right angle triangle. So this is 22 as well. So we know what's BEC. So BEC is equal to half times 11 times 22. So we can cancel 2 and 22 because 11 is the base and the height is 22. So then we can just, this is 11. 11 times 11, 1, 2, 1. Right. So now we know that this thing over here is 1, 2, 1. And we know that this figure over here is 198. Then we can get finally this triangle, right? So this triangle AFB, AFB is equal to, basically to get this AFB over here, we need to get the whole of the square minus the highlighted blue plus the highlighted purple to get this triangle over here. So AFB is equal to the whole of the square, 22 times 22, then minus the 2, we need to minus the BEC, which is 1 to 1, minus 198 over here. Okay, so 22 times 22 is 484 minus 121 minus 198. So I'm going to calculate this. 484 minus 121 minus 198 is equal to 165. Okay, 165. Okay, so now we know that this whole triangle is 165. Then the next part is, okay, this triangle is 165, 1122 cm, cm. Okay, now we can actually get this triangle. So since we know this half over here is ABD, so triangle AFD, right, which is this one over here, is equal to, so the half of ABD is 242 minus 165, right, which is equal to 242 minus 165. This will give us 77, right? So now we know that this part over here is 77. All right. Now we need to know this other triangle. Oops. This other triangle. Just draw this. So we need to know BFE. So we already know AFD. How to get B, F, and E? So the thing is that if we were to look again, right, let me just remove this. Okay, so BFE, there is a triangle over here that we know of, this. So we know this triangle, and then we also know this little section, this triangle as well, which is 165 over here. So if we can get this big triangle minus this AFB over here, we can get this triangle as well. So what we can do is we can get ABE. So let me do this over here. So triangle ABE is equal to, so let's see, ABE. All right, so we have ABE, which is basically the base over here is 22, and then the height is in the middle, which is basically, the height itself is in the middle, which is the same height as the square. So it's basically half times 22 times 22. Okay, I think we know the answer to that. So half times 22 times 22, which is equal to 242, right? Now we know what's the whole ABE. Then the last part, the blue part, I'm just gonna draw this part over here. Okay, so this blue part is basically the red triangle minus the gray triangle equal to the blue triangle that we are looking for. Which is basically ABE minus ABE minus the AFB. Okay, so this will give us BFE, right? So BFE is equal to the big triangle 242 minus 165. And this will give us 77. Right. So now we know AFD. So AFD is over here, which is 77, and BFE is also 77. Now we can get AFBD. So we can swap the values. So AFBD over here is equal to 198 minus AFDE is 77 minus BFE is 77 as well. And this will give us, so let me just put it here. Let me just, let me just write it down. So 198 minus 198 minus 77 minus 77, and this gives us 44. So the answer to the shaded area is 198 minus 77 is 44. So the answer is 44 centimeter square. Whew, that's a lot, right? Yeah. So this is one part of the answer over here.